Okay, so from the question, it says we must prove that APNM. We get APNM is a parallelogram. Okay, is a parallelogram. That's what we need to prove. This is a parallelogram. Okay, so they gave us ABCD is a parallelogram. They told us this one here is a parallelogram. Okay? And they told us you can put it in. When they say something, you can put it in. DM is equal to BP. So they said that DM is equal to BP. And they also said that DC is equal to BN. DC is equal to BN. So it's pretty clear that to prove that this is a parallelogram, we're just going to show that the diagonals bisect. That's the way to prove it. Okay? Remember, there's different ways to show it's a parallelogram. You can either show that the opposite sides are parallel, both pairs of opposite sides, or you can show that the diagonals bisect each other, or you can show that both pairs of opposite sides are equal. But in this case, because they told you what this one is equal to that one, and this one is equal to that one, it's clear that we're going to try to show that the diagonals bisect each other, and then it has to be a parallelogram. Okay. So what we can start with is we can say that DM is equal to BN. Okay, we can say that. We can say DM is equal to, why can we say that DM is equal to BN? Because it's the properties of a parallelogram. Okay? Diagonals bisect each other. Diagonals bisect. Okay? Because I told you ABC is a parallelogram. So you know this side must be to this one. Okay? And then we can also say that this side CD is equal to AB. We can also say that CD is equal to AB because it's the opposite sides of parallelogram. Opposite sides of parallelogram. Okay? So that stuff we know. Because they told you ABC is a parallelogram, you can say that side is equal to that. This side here, or this part here is equal to this part. This side is equal to this side. It's a property of a parallelogram. So then we can say, therefore, if DM is equal to BM, but we know that DM is equal to BP, we can say, therefore, BM is equal to BP. BM is equal to BP, and we can say that if CD is equal to AB, but CD is already equal to NB, then NB is equal to AB. NB is equal to AB. Okay? And then we can say, therefore, this thing here, APNM. APNM is a parallelogram. And our reason, diagonals bisect. Diagonals bisect each other. Okay, so we can say it is a parallelogram. The diagonals bisect each other. Does it make sense? Oh, sorry, yeah. BM. Okay, where did we say that? BM is equal to BP. Okay, BP. Okay, does it make sense? Do you understand what I mean? I'll just go through it again. Listen to the process. Now you must think about it. You want to prove that APNM is a parallelogram. That's what you want to prove. Okay? You need to show APNM is a parallelogram. One of the options of showing that it's a parallelogram is showing that the diagonals bisect. If you can prove that the two diagonals bisect, then you can say, therefore, it must be a parallelogram. Okay? There are other ways to prove it's a parallelogram, like saying that NP is parallel to AM, NM is parallel to PA, or the opposite sides are equal. But we're not going to do that because they didn't tell you any of the parallel lines here. They didn't show you any of, so you're not going to use that. You're going to use what they gave you. They gave you that DM is equal to BP. DM is equal to BP. And they gave you that DC is equal to BN. So So you need to ask yourself, why is that what they gave me? Okay? So they gave me a part of the diagonal. They gave me that part of the diagonal. So they say, okay, well, if that's what they gave me, I'm going to use that. That's one of the ways to prove it's a parallelogram, that the diagonals bisect. So you're telling yourself in your mind, if I can show that VM is equal to BP, if I can show that, this point, and if I can show that NB is equal to BA, if I can show that, then I can say it must be a parallelogram. Because the diagonals bisect each other. So you're telling yourself, okay, probably for 5 marks, all I need to try to do is to show that this part here is as long as that part, and this part is as long as that part. And then you use what they gave you. They gave you CD. Say, okay, wait a minute. If CD is equal to NB, okay? Or if CD is equal to NB, but I already know that CD is equal to BA because it's the opposite sides of the parallelogram. You can even put it in. You can say, wait a minute, they told me ABC is a parallelogram. That means this one must be equal to this one. I can say CD is equal to AB. Why? Because it's the opposite sides of the parallelogram. So I can say that. We're full right because I know it's the opposite sides. Because it's given that it's, then you can say, okay, well, if this is equal to this, but this one is equal to this one, then those two must be equal to each other. Okay? And in the same way, you can say, wait a minute, MD must be equal to BN. MD must be equal to BN. Why? Because it's the diagonals that bisect. Because this is a parallelogram. So the diagonals must bisect. Because they told me ABC is a parallelogram. So I can put this in here. I can put it in. Okay? It's a property of the parallelogram. So if DM is equal to VM, but they gave me that DM is equal to BP, so then if DM is equal to this one from the start, but I just said that DM is equal to BM, then it means that BM and BP must be equal to each other. And there I prove that the diagonals bisect, and because they bisect, I can say therefore APNM is a parallelogram. Does it make sense? So it's using what they gave you to prove what you need to prove. That's how proofs work. Okay.